Okay, let's tackle this question 15 of this exercise 5e. So let's look at the function. It's an exponential function, well, not entirely, but so find and classify any stationary points of a function. This should be straightforward. It means we need to find the f prime, and that is, you see, is 1 minus e to negative x. So we set this to 0, right? And the aim is to find any stationary points. And if you do this carefully, and now this can't be anything else but that x is 0. Okay, and of course you have to test this point. So for 0, so you choose a value slightly smaller than 0, say 0.1, negative 0.1, could be negative 1. You substitute that value back into the f prime function, so let this be that value and see what you get. The sign is very important. The sign of the value would be negative, and you do the same, but choose a value, say 0.1, right, and substitute that 0.1 value back into this and see what's the sign. You might find that you would find it is positive, and there you are. So now you find the corresponding point. So when x is 0, your f0 is if you check carefully, this is 1. So you might make the conclusion that the local minimum, of course from the sign diagram you can see that, is 0, 1. Voila, done. So the part B, okay. Now part B, discuss the function as x tends to negative infinity. So now this is the function. Again, if you note, you might notice that as x tends to negative infinity, this e negative x would tend to infinity. Why that's the case? Because you see, this is e negative x, or 1 over ex. Now if the negative x gets more and more negative, so what I'm trying to say is that we'll get something, calculating something like this, say a huge number, say a million, 1,000. So this is going to be really small, and that's why it's going to be undefined, and that's why it will tend to be infinity later. So hence, when you do this, it tends to infinity, and what will happen to the graph? Yes, the function would tend to infinity or so. Now this is because this is going to grow really large. Okay, now let's move on. The part C, explain why the graph becomes more linear as x gets large and positive. Now let me change the pen. So it's very simple. If we look at this similar, using the same approach as how we tackle the part B of the questions. So x tends to positive infinity. This term now tends to 0. Right? Think about it, because e negative x is actually 1 over ex. If x gets really big, this is something like 1 divided by a really huge number like that, and of course this is going to be really small. So when x tends to really huge, this term tends to be 0, and so that means the function would tend to be x, right, because it came from this x, efx. This term going to be 0. So as x gets really huge, you'll be left with this term only. So it tends to this x here. So what does that mean? This y equals to fx or what have you x is actually a line like this. This is a line like this. Okay. this line, but it's not here. You see, this is when x is really huge. You see, it behaves like a line when x tends to be really huge. So that means this line, so fx becomes more linear as x tends to positive infinity. Okay, now hope you can get that. Now moving on to the next part. Okay, this define f double prime. Let me get the pen again. Okay, so find f double prime. F double prime would be e to the power of negative x, which is 1 over ex. But that means this is greater than 0 for all x value, right? Because you don't care, just substitute any values of x and it still be positive. So that means that the function is convex, right, for all x. Where we are. So then sketch the graph of this. Now how do we do that? Well, you can use a calculator, of course. If you're smart, just use a GC. But it's a very easy to sketch actually, because you have so much information. Now first of all, we know that the graph actually is convex, means that it's always like, behaves like this, always convex, the curve side, pointing up. So the curve going to shape like this. And the other thing is, we know that when x is 0, this is a local minimum here, right here, 0, 1, and since it's a minimum, so we know the rest of the graph will be above this, will not cross this line here. So here we'll suspect that it might look something like this. Okay, and this part tends to be really going to straight line. Later it will be something like a line, because this is where there's asymptote there. And you can check this with a calculator. It's a good practice to do that always. So lastly, deduce this. Okay, how do we do that? So it's actually fairly simple, because we know the minimum value, and we know fx is x plus e negative x is given, but fx is greater or less than 1. You see, this is the minimum point, so any part of the curve would never be deep, you can't go below this line here, this point value fx is going to be less than 1, maybe at most just equal to 1. So this is a case, this is true for all x. So that means x plus e x greater than 1. If you rearrange this, so this is shown. Okay, so I hope you do it and try. Hopefully you can understand this problem.